Right, guys, we're going to talk about um, just how we're going to present our problems. Um, so this is a little bit kind of an overview of how they'll look, kind of formatting flow, and then you'll see I'll do the problems in the videos the same way every single time. And I'm going to write this across the top. Um, we'll do so. There's the first, technically two steps, but I kind of combine them into one. You're going to have a picture and variables. And I'm going to go through this again, but this is just to stress this. That's kind of that's your starting point. Every single problem, that's where you're going to start. Now, picture doesn't necessarily mean drawing an all full out picture. Usually it's arrow representations. I only really stress it if there's a lot of information and you need to break it up into parts. I definitely suggest drawing a picture. You'll see when I'm doing the problems, you'll see me drawing pictures when I think you should draw a picture. If the problem's pretty straightforward and doesn't indicate any changes in direction, I kind of just picture it in my head and move on. Variables, you definitely want to make a habit of listing out. Sorry, hard time saying that. Listing out the variables, because that's going to that's going to lead you to the next step. So, which is uh, trying to find the relationship, which we will write as an equation. Sorry, my writing sloppy. As an equation. How do we know which equation to use? It comes from the variables. Now, this chapter only has one equation, but that's not true of every chapter. So just the variables become important in telling us the equation, and then it's a step by step. It's a logical processing thing where you can kind of work through the problem in steps. Once you got the equation, then you're just going to, what I call setup. You're not going to do any math yet. I just want to make sure you know where everything goes. And then that's the setup. After you do the equation and setup, then we get to this, then there's some math. But here's the deal with math. You don't ever have to show it to me. Like that's going to be you on like a scrap sheet of paper. Uh, Here, I'm not going to write that out, but that it's on the side. Like it's not something you have to write on this slide for me. Some people like to rearrange the equation and then put the numbers in. Some people just go with the setup equation that has the numbers in it and just solve it. At this point, I'm really open-ended on how you do it. It's kind of your preference. And then that last step, once you do that math, is an answer. But again, that the math step, you don't have to take the time to write out on this slide. You can definitely, I suggest doing that kind of stuff on paper. It'll stick in your head better. All right. So solutions must be presented using the following formatting. So what I mean by solution is not the answer, it's the picture variable equation setup answer. Uh, and here my little warning. If you have all that information, but it's not formatted in a logical way that someone can understand, I'll put a needs improvement sticker, um, and then you'll have to fix it. You'll get those points back, but I need it fixed. And then all equations must come from equations discussed in class. If you pull out an equation that we haven't discussed before, I need to know why and where you got that from. Like there needs to be a discussion before you start bringing in outside class stuff. Writing out a physics problem is analogous to writing a paragraph, right? When you write a paragraph, you're going to have an introduction. That's your picture and variables. You're going to support, right? You're going to support that introduction statement with some backup, I don't know what I call them backup, but additional sentences, right? You're going to have more information that's supported. And then that's our equation and setup. And then the conclusion of a paragraph for us is going to be the answer. So you are presenting me. I know it sounds weird, but when you hand an English teacher a paper, you do it in that order, right? You got an introduction, support, conclusion, or they kick it back to you. Physics problems, you're going to do the same way. Um, Actually, I'll be honest with you. I say all math problems you should kind of do the same way. Like you got you got that introduction point, the support, the equation setup, and then you got some answer. Problem solutions will be read left to right, just like we read a sentence. Most of us are going to read left to right. We grew up reading left to right. I know there are other variations of that, but I'm going to say the majority of us are familiar with left to right. It's hard to write left to right digitally. It's much easier on a piece of paper, so we will also, what is acceptable would be top to bottom. Um, if your solution's too out of order where I can't follow your logic, then again, I'll kick it back to you and you'll have to make some corrections. Digital work, oh, I already said that. So again, they should have a clear logical flow. Now, I will tell you, you could also, so here's, you know what I mean? You can work down the page. That's top to bottom. There's also the possibility that we could write, you know what I mean? You could start across the page and then come down. Just so there's some logical flow to it. Like I shouldn't have to be your answer shouldn't be the first thing, and then the equation's way at the bottom of the slide, and then you have some work off in the corner. Like nobody reads like that. Uh, I mean, graphic novels, I get that, but even that has a kind of a flow to it that you can sometimes tell what's going on. But just just be cautious. Sometimes these will get kicked back, not because you're wrong, but because I just couldn't follow what you were trying to tell me. Um, all right, so here's some. So again, picture and variable should be together. That's one. Those go together. Equation and setup, those also go together. How you set it up is based on that equation. After that, you can do whatever math you want. You can rearrange the equation. Um, you can solve the math outright, whatever you want. You don't have to write that stuff out. Equations can't come before variables. I don't, I understand sometimes we will know the equation before the variables, but that's not going to be true for always, right? Eventually you're going to learn more physics and there's going to be more options. So you need to make a habit of writing out those variables. And then just to remind you about AI usage, this is the last thing. The I'm okay with it, but you got to ask it to explain it, and then you can't just copy and paste it in. If you're writing me a sentence in the middle of a problem, like that's not us. That is not how anyone does any problem, right? Any math problem. You don't write out sentences in the middle of the problem explaining what you're doing. That's an AI thing. So you got to clear out all that junk. Like I just want to know that you know the variables, the equation, the setup, and the answer. Um, so again, cautious with AI. You can ask it for help, but you should not just ask it for, hey, give me the answer to this, because it's you still need to process it. I can't stress that enough. Like process what it's giving you. Don't just copy what it's giving you.